All right, so this last part of the workshop is going to be all Robots4Whales, so real time. I'm going to walk you all through the Robots4Whales website and how to access things there, and then I will walk you through the species analysis protocol. So this is applicable for anybody who wants to run gliders with the real-time system, but also folks who want to learn about some baleen whale species ID. There'll be some a lot of examples here as well, and we'll see a lot of examples of what they look like in the pitch track data, which is pretty fun. So, to orient you with this lovely reference guide, that there used to be a more beautiful version of this that was a lot more pleasing to the eye, but of course we went through the government process of getting it published, so of course now it's a bit boring. But so part 2 of the whole reference guide is all real-time related. And so if we go down to the right section here, we can see a layout very similar. This is what Mark just presented. It gives you a run through of how the system works from satellite transmission all the way to the pitch tracks getting uploaded onto the Robots4Whales website. There's an example for a glider and then an example for the moored buoy system. So you can see that there. And then there are descriptions of the different components of the Robots4Whales website in the reference guide here, if you want to look it up there. But it's much easier to just see it in the real thing. So robots4whales.hui.edu. This is where, if you are operating a real-time glider, this is where you're going to access all of your real-time data. So all the raw pitch track data gets uploaded directly to this website every 2 hours from the platforms. So if you scroll down here, the latest detections section here, these are all of the currently active platforms. And hopefully currently active.
Yeah, I was going to say Atlantic City is not.
Have some malfunctions currently, but we have a lot of buoy turnarounds coming up in the next few months. So we'll have some new ones and some repairs going on. But so each of these are live links that will take you to individual project pages, so you can go in and see each particular platform. All of the information is publicly accessible, so you can go on and see what's been detected on each platform, which I'll show you all the project pages probably after the break here. You can also see a quick look at what's been detected on each platform over the last 3 days. So a little glimpse here. So like, for example, Central Gulf of Maine glider, we've had sei whales in the last 3 days. And you can see the operators and collaborators there. There's also some maps here, so you can see the general locations of where all the platforms are located. We have our one little Santa Barbara buoy over there on the U.S. East Coast. And this is the website still undergoing a bit of a facelift, Mark? Like the main
yes,
page?
Yes, we're so close.
Oh, good. So yeah, so at some point when you come here, it might look a little different. But all of once you get off this main page here to the project pages, it'll all look the same as what it does right now. What we'll see today, right, Mark? They're not going to change much in the background.
No, the background stays the same, but this page will change.
Exciting. Not that we don't love the current version, but
it's very 2000 and
yeah, it's very
well, it's really about 1995. That's when I started. No, 1992 is when I started my HTML coding, and I have not advanced since then. So this is very,
it's like
very.
The modifications I made to my MySpace page.
Yes.
I know.
Because I was aging, I was like, when did I make my MySpace?
That hurts, nice. But it's not untrue.
I know. I'm just gonna be very quiet.
Dude, it was put together by a scientist, not a web designer.
It's great. It's actually, can they keep this color scheme, because it just makes me happy.
It's okay. Like the Tetris color scheme.
No, it's the Tetris color scheme.
We're using whale icons now on an interactive map.
Oh, well, that's exciting.
Anyway,
whatever.
Okay, so as you keep scrolling down, there's this there's this scrolling window here where you can access literally any real-time deployment that has happened since the beginning of this project. I think the original test deployments were in like 2012. So within this, you can see the same active missions. These lead to the same project pages as you saw above at the top of the page. But then below here, you can scroll. We have all of our archived missions. So you can go through and see, okay, we have, old Santa Barbara channel, buoy deployments, Cox Ledge, coastal New Jersey. Like, we have all of those with the start date of when those happened. And I do want to draw attention to one deployment down here at the beginning. It's this Roseway Basin. It's on the Scotian Shelf off Canada. This deployment is a really cool one to go in and look at because you can actually go into the pitch track data, which I'll walk all through this a little bit more slowly after the break. But just to show you, this is one deployment that Mark laid the actual archival data next to the pitch track data. So we don't get, this is what we don't get in real time. This is what we get after the platforms are retrieved. What you see on the left-hand side here is the pitch track data, and this is what any real-time analyst would see in real time. So it gives you a glimpse into why I love pitch track data so much, because it's so much cleaner and nicer to look at. What we have here in the raw audio, we have, like, I think this is the buoyancy pump going.
That's the buoyancy
of
pump.
the glider. The rudder noise, which are these impulsive sounds here, broadband sounds. So as you scroll down, you can see how much the pitch track data actually filters out for you. So you're not seeing a lot of this distracting background noise. And it does pull out some of the real calls. You get all of the buoyancy pump noise filtered out. Here we see a couple of say whale downsweeps. So this is where it's actually picking up the real biological calls. So we see a say whale doublet here. This is very characteristic of say whales. One of those calls is classified. It's got a little, that's the number 1. That's one of our say whale call types. Here we see some fin whale pulses, 20 hertz pulses, one of which is classified. Usually it's pretty good about classifying them. But if you scroll over here, you can see those same calls in the spectrogram. So it gives you an idea. I love scrolling through this deployment in particular because it helps you kind of visualize what the pitch tracks are giving you in comparison to what's actually happening in the full audio. So that's just something that I wanted to flag, was that Roseway Basin deployment. But any of these projects you can go in and take a look at. We keep scrolling down. You see this image that we've never seen before. Totally new. And then just if you missed the whole first half of this workshop. And then it keeps going down. Mark added these clips. This is great if you are familiarizing yourself with baleen whale calls. There's just some quick clips here. There's a fin whale 20 hertz pulse train sped up by 24 times, so you can actually hear it because they're quite low. And then humpback whale singing a few different audio speeds. There's also the NOAA's, the National Oceanic and Atmospheric Administration Sounds in the Ocean webpage, which is a great resource to go on and actually just listen to some different sounds from different species. But there's a few samples here. Pictures of the real platforms themselves. As Mark said, we mostly work with the Slocum gliders and the moored buoys. Some brief descriptions. We've seen this one before, just a depiction of how the Slocum glider works. Yes, Lee?
Is the website pulling the pitch track data from, are the Slocums, the buoy, joy glider all calling a single iridium location, or is the website harvesting from that, like, from the communication? The person who's flying the gliders using their base station thing.
Yep. So for my gliders all call into one dock server, one computer. All my buoys call into another server, and then those data get synced with a third computer that actually runs this website.
Okay.
But we also have glider operators at other institutions. So, for instance, Rutgers is doing some glider work with a DMON off of New Jersey. So their server their doc server is connected to my server that runs this website and pulls data from them. So I'm pulling from a number of different organizations from their doc servers,
Okay.
as well as my own doc server.
And what this comes from is not what you're also using then for the glider.
No,
Okay,
this
that's
isn't
all
sitting,
separate.
no, this
Okay.
isn't the docs, the Iridium communication computer.
So if someone else had not started doing this, like
Yep.
Southwest,
Yep.
we'll be able to send you their, once their
Yep.
EONs get installed,
Yep.
and add it to the same.
Just need to have a connection to your doc server, but
I
that's
think they'll
pretty
probably use, I
straightforward.
think they use Teledyne most.
Even better, because I'm already set up to pull
Yeah, I
glider
think they
data
pilot
from.
with their official
Yep.
setup. Because NOAA IT won't let us have our own.
Yeah,
Okay. All right, so the last few things on the main page here, under resources, you have your acoustic diagnostics page, which just gives you a little bit of information about the various platforms that are out. And so this first plot here shows the percentage of time that pitch tracks are available over the last 3 days per platform. So each of these bars, like this is the Santa Barbara buoy, this is the New York Bight buoy, Atlantic City, and the pink are the gliders. So it just gives you an idea of how much data we've been able to look at that's been transmitted over the last 3 days per platform. Scrolling down, this is just a count of any of the other detections. So these are ones that they were classified as a species, but they had a Mahalanobis distance over 3. Is that what? That's
Yes.
what.
Yeah,
What we're counting as others. Yeah. And so it's basically anything that we're not really considering classified because they weren't a close enough match to the exemplar call types.
And
so
that's
just
typically noise or humpbacks.
yeah, exactly. So you can see like Cape Charles is a bit noisier at least over the last 3 days. This is just kind of a glimpse into what's going on. We have the power spectral density plot, so you can get an idea of just the general noise conditions of each platform there. We have them split up from buoys and gliders. And then if you keep scrolling down, these are also, we'll see these on in the raw pitch track data. They're displayed on each pitch track page. The pitch tracks are transmitted in 15-minute chunks worth of pitch track data, and at the top of each of those individual pages, we get a sample of the background noise over the last 3 days. But here you can get it over, I think, the whole deployment for each platform.
These are just the last couple of days.
Oh, it is just the last couple of days.
This was a page that I put in to help me keep track of audio.
Okay.
So it's also sending a snippet of raw data to me.
This is the background noise spectrum. So you remember early this morning, one of the first things I said was after you make the spectrogram and you smooth it, you equalize it. And when you equalize it, you use this running background mean. That's what this is. I actually save that thing. No, I shouldn't say that. Every half hour, I'll go and grab the current mean background spectrum and I'll send it home.
Okay.
And that
So
becomes,
it's
it's
just
not
a
a
very
long,
small.
yes, it's short, but it's basically a representation of the long-term spectral average. And so in it, what it's really good at is getting ship noise. Ship noise and weather, essentially, are good.
It's sometimes
And
nice.
you'll see as we scroll down, there's, like, go to Ocean City, there's nothing but ships there. In New York and Atlantic City, yeah, Ocean City's got a ton of boats that go by there.
Sometimes you can see like the tidal patterns and stuff on it. Like if you're getting a bunch of low frequency noise on your platform, you can
we'll see storms on this very easily.
Yeah. So it's just kind of a summary page that most analysts don't probably look at very often. There's a link here. There's a direct link to the reference guide. So if you click that, it'll take you straight to the download link. There's also the training videos here. So this is a very similar version that we did at the DCLDE conference in 2022. So if you forget anything that you heard today, you can also look it up here. We also, of course, recording today as well. So there may be some new recordings up that you can access. And then publications, and that's it for the main page. And we've got 1 minute until the break. So I think we'll pause here, and when we come back, I'll walk through just a sample of what a project page looks like, how to access the raw pitch track data, and then we'll go into the species analysis protocol.
I just have a question about the gliders.
Yeah.
Because so the fixed mooring, they have a position, and okay, it's for maybe a monitoring project. But the gliders, do you have like specific project, and you say, okay, this glider, I will make it go this way, or how do you choose the path of the glider?
Depends on the project. Depends on what the objectives are. If there are science objectives or
it's not
otherwise.
just monitoring. It's not for one big monitoring program.
No,
it can be
no.
different projects.
They're each of the buoys, virtually each of the buoys are paid for by a different sponsor. The gliders are typically, I don't know, in some cases the DMON is sort of a tack-on, like the Cox Ledge stuff was mostly about fish monitoring, and we tacked on the DMON monitoring with that. I do a survey in the Gulf of Maine every year. That's dedicated for baleen whale surveillance. And that was a survey design that I came up with that covered the right places, and got the glider home in time. And then we were talking about the Central Gulf of Maine glider, which is actually at sea right now. Actually, you can show that.
Sometimes we'll have tracks and be like, oh, we should switch them for the next time, or tweak them this way.
Like this one, I think we switched a little bit, because there are a bunch of bottom-mounted recorders around this area, but there was kind of like a little bit of a gap.
A gap, so we're gonna fill that with this glider.
Oh, it's doing a nice round.
Yeah.
It's laboring, the tidal currents are just wicked out there.
Ooh.
Yeah, this gives you a look at, we're into our break now, but we'll take a glance at this.
We lost our fin whales.
Okay, but they all have different purpose, but everything is gathered on the website. So
Yep.
Yeah.
it's great because
It's a one-stop shop for your baleen whales.
they're all dedicated to different things, but in the end, you have all the information in one place.
We have collaborators at the University of Maine who were initially funded to do like some right whale centric stuff, but they are physical oceanographers, and they're like, Mark, we have these other things, these other projects that we're funded for, but since we have the DMON on, we'll just turn it on, which is actually what I wanted all along, because just kind of wanted to sneak it on there. And once they're like, hey, this isn't bad, like, and it helps.
How long does that reduce, how much does that reduce their mission time by?
The DMON is really, really low power.
And I guess you're sampling much lower. So like you don't use for the sea glider, you run out of storage space.
Storage space is an issue on the DMON. We have to duty cycle it my gliders, like that Gulf of Maine mission is a 4-month mission, and we can't do full-time high frequency
Okay, so
stuff.
if they're gonna you can duty cycle so that they can still do their whole mission, but you're getting something along the way.
Yes.
Okay.
Yep. We don't duty cycle the low frequency. We can record that continuously, but if we wanted to add high frequency, we'd have to duty cycle it.
For the Robots4Whales website, just the last thing here are, I'll run through the project pages specifically. So this is just an example. It's our Central Gulf of Maine glider that's out right now. So when you click on a project page from the main page, these are the active missions here. So this is just when I've clicked on, takes you to that specific project page, has the study objectives, the principal investigators, the analysts, usually a photo of the platform itself. If you scroll down, this is the current glider map. So this is off of Cape Cod, Massachusetts in the US, and the green is where the glider was deployed, the red is where it was, the location at its last transmission, and these gray lines, Mark calls them the drunken sailor lines, that is the glider track. So they're subject to the currents a bit, so when they're diving down, they might get off course a little bit. So when they come back up to transmit, they'll course correct a little bit, which is why you get a little bit of a a wavy line there. So this glider has been serving north of Georges Bank for the last couple months? No, for a little bit.
2 months.
Yeah, so if you scroll down, there are plots of the species detections, and so these are the human analyzed, this is like the results of the human analysis. These are not just from raw detections on the glider. So this is when an analyst has gone in and said, like for example here, a sei whale is detected at the red locations or possibly detected at the yellow locations, and we have a specific protocol on what constitutes detected versus possibly detected, which I'll go through briefly with you. The fin whales here you can see are just there almost all the time, except this, we're mystified why all of a sudden they've gone quiet.
I noticed the cross legs, they're gone too.
These little,
Yeah. Isn't that weird?
I don't know.
Shallow area.
Yeah,
No.
I'm not sure, but then, yeah, so right whales you can see are much more rare.
The new website gonna overlay the symmetry.
At least right now.
What's that?
And
Are we
then
gonna get
humpbacks
symmetry in the
are
new
similar to fin whales in the sense that
Good.
they're pretty much
I can put it
there
up there.
all the time for a lot of these deployments. So if you scroll down, this is the daily analyst review table. So if for each day, this just shows daily presence. So red for detected, yellow for possibly detected. I think Mark explained a little bit of this. Gray is just not detected. And so you can go into each one of these days is a live link that you can click into, so you can pick your day, click into it. It will list any periods that were either scored as detected or possibly detected, or periods where we took any notes. So those are compiled down at the bottom here. So if the
Julianne,
analyst, yeah.
can you share screen?
No!
I'm so sorry.
It probably, oh my gosh, I'm so sorry, online folks. It was really glitching out earlier. I wonder if it
Oh, I wonder if that did it.
stopped its sharing. Oh my gosh, thanks Gabby for playing that. Okay,
It's okay, it's only been 5 minutes.
yeah, you're right. So for online folks, I'm so sorry, I apologize. We're down here, so on the project page, I just picked the Central Gulf of Maine glider that's out right now. If you scroll down, this is the daily analyst review table that I was talking about. So you can click on any day. It doesn't matter, we can go down here. There's a couple, we call these the Grand Slam days, when we get all 4 of our species detected in one day, which is always exciting. So you can click there and see what's been detected. Each one of these are live links as well, so you can click straight in and see the raw pitch track period. So this is what the actual like raw pitch track data looks like. So when you click in, you can see the summary of detections at the top. So these are, or the summary of classifications. So this is the raw detector output as far as what it thinks is there. So we have 2, so just looking at this without even looking at the pitch track data, we see, okay, there are 2 sei whale classifications. We had 41 fin whale classifications, no right whale or humpback, and we had 68 of those other classifications. And then we have the duration of the period in seconds. So, yeah.
Should we mention, so we do not have the call library Gulf of Maine 9 on here. This is using 7. Yeah, so we didn't add a ton of humpback whale call types that are on here. It doesn't matter because you're looking at all of the pitch tracks, so you don't need to look at the classifications. But when we go through the archival data, we have the humpback classifications to be able to look at just that, just to clarify in case that.
Does the glider go out with one set of call libraries? Can that be updated remotely? Like if you were to
No,
update it or no?
that can't be updated remotely. I was just thinking about that the other day. No.
But that's fine, because you can rerun it once it's back in.
Yep.
If you needed
Yep.
to, if
Yep.
you're
Yeah.
focusing on that stuff.
Yeah. And you can update the humpback call library. We've just, at this point, we can take context into account, so we haven't kept it updated every single year with new call types or anything like that. It's
not terribly informative. It doesn't help
Yeah.
the analysts very much,
Yeah.
whereas the other species, the classifications do help.
Is
Yeah.
there a processing cost the bigger your library gets?
I mean, if the library was huge, we might have memory issues on the debug because that's a limited resource as well. But we could probably double or triple the number of call types and not it'd be a big deal.
Okay.
Yeah. So at the top of every pitch track page, you'll see the background noise spectra. These are the same ones that we saw on that diagnostics page. So for gliders, you'll see these black bars. A lot of times these are when the glider is surfacing to transmit data, so that's when it's not recording at that time. So this can give you, it's good to take a glimpse at this when you're doing analysis, just to get an idea of what the noise conditions might be for your current pitch track period. It shows the last 3 days. And then you scroll down, and this is your actual pitch track data. So each row is a minute worth of data, and we call these panels. So right, panel 1, panel 2. So if you're taking your notes, right, you're like, okay, you know, possible unclassified say whale doublet in P3 or panel 3. So as you scroll through, we have some classifications here that could be fin whales. There's some difference in the INI or the internote interval here, but this is where we get our classification information. So underneath each pitch track, if it's classified and the Mahalanobis distance is less than 3, it'll show the classification number, and we consider that to be classified in real time. So call type 4 is our only fin whale call type for this call library that we're using, and then underneath it will display the Mahalanobis distance. For the purposes of analysis, we don't really pay too much attention to the exact Mahalanobis distance because we know it's only going to display the classification if it's under 3. So you don't have to psychoanalyze that number too much. And so, yeah, so if you keep scrolling down, here's a bit of a cleaner fin whale pulse train of those 20 hertz pulses. And there's, like I think it's the Rutgers gliders that's out right now. Sometimes the rudder noise, so in that Roseway Basin deployment that I showed where it has that impulsive regular noise of the rudder going back and forth, sometimes that'll show up as, it'll look kind of similar to fin whale pulses. But you can determine fin whale pulses. What helps is looking at the literature and seeing, because their internote interval will change seasonally, at least in our region. So we've determined that in the kind of spring to summer months, the interval between these pulses is kind of this 15 to 16 second interval, versus in the fall to winter months, it transitions into a shorter interval. So they're like 8 to 9 seconds apart. So it can vary. And typically as part of our analysis protocol, we do pay attention to what that interval is because it can help distinguish. Sometimes if there's, like down here, we can get some low frequency noise, which we do provide like a full 2-day real-time analysis training. Like if you're actually going to do the analysis on the gliders or the buoys, you would go through a full 2-day training for this, and we do a lot of practice of what is noise and what is biological. And so a lot of this is just low frequency noise here, but we can see that the fin whale pulses get pulled out and classified. And then here we have a nice say whale doublet. And you can see a little bit of a gap here in the pitch track, which might be because of that, the background noise getting filtered out. And we have at least one good classification there. Yeah.
So in that case, you have 2 pitches. If it's good.
Yeah. So technically, so that could be a reason why this downsweep in particular didn't get classified, or it did, and it's just has a higher Mahalanobis distance. Fortunately, this one did, which helps. Part of our protocol, which I'll go into, is at least one of those pitch tracks has to be classified for us to consider it say whale, because the classifier for say whales is fairly dependable, and we rely on that as just an extra bit of information to say, like, yes, they're there, the classifier has matched it to our call type.
The nice thing about say whales is if they present a doublet like this, it's almost completely reliably diagnostic of the species. It's actually really wonderful.
Yeah.
It's always like they're 3.5 seconds apart. It's like you can bet money on it. So that's really nice when you see something like that. It makes the analyst happy. At least it makes me happy.
Humpbacks can, because of their humpbacks, they do produce low frequency doublets that look a bit similar, but they're usually in like a very clear repetitive pattern. So you can pick those out pretty easily. So once you scroll through and you've looked at your pitch track data, you can scroll down to the bottom.
That dash line.
Yeah, I know.
I'm sorry.
Jeez. You can scroll down to the bottom. Don't worry. And you have your scoring table here, that where you can select, detected for say whale, detected for fin whale. The default is not detected, so you would just leave that where it is for those species in this case. Any notes you wanna put in, and then you would click the submit button, and it will, the first time you do it, it'll prompt you to log in. So not just, anybody can go on and analyze the pitch track data. So Mark would give you a username and password for this. If you scroll down further, there's lots of good information about what else you might see in the pitch track data. And just some tidbits. So it'll be in your local time zone. Anything above 10 decibels or more above background noise, or 11, I guess, which Mark's already gone over. This is helpful right here. This is just a summary of the call types that the classifier is using in the real-time data. So if you are seeing those little numbers underneath the pitch tracks, sorry for the scrolling, like this, those little 4s, and you're like, you forget what the 4 means, you can come down here. 4 is for fin whales. In this case, we have call types 1 through 3, which are say whale call types. 5 through 8 are right whale, and then we kept a couple of the humpback call types in there, the 17 and 18. Specifically, we'll see these in the analysis protocol. Call type 17 is a very similar humpback downsweep to say whales, and so there's actually a little bit of crossover. It'll pick up say whale downsweeps occasionally, and we can take that into account. Usually we have to take context into account as well. So if it's a nice obvious doublet that's isolated from humpback song, but it's classified as call type 17, we actually do count that as a say whale call type at this point. Call type 18 is those humpback kind of upsweeps that Mark described, those like whoop. Sometimes those get, like the call type 18 will classify right whale call types as that. So we've kept those in because we know there's some crossover that we can kind of use to help our analysis. And then down here are a few codes that you might see in your data. So this corresponds to the vertical dashed lines that you'll see occasionally up here. So this is like ADD, ET off. So when you see that, you can scroll down, and that's when you've reached your data limit of 8 kilobytes an hour. So that's when you've had all your pitch track data. That's your cutoff. It'll keep recording on the platform, but you won't get any more. You won't be able to see any more pitch track data in real time after that point until the next hour. So that's what that means. There's mute on. Sometimes it'll pause to assess system noise. Mute off. It'll resume. The ADD, ET on. That's when it'll resume for the next hour to resume pitch tracking. And then these codes, these last two ones, are when the glider actually surfaces to transmit. So that is what the pitch track data actually looks like. Another way to access this data from the project page, because this way we were only just going in to see the ones that had already been scored. If you want to see all your pitch track data, which Mark showed us a version of, you can scroll down to the bottom. I'll talk about those things in a second. Down here, automated detection data. This is the bottom of every project page. You click that, it will give you a plot of your raw detector output of the classifications. So you can see what's getting classified. There's a lot of fin whale classifications. A lot of them are probably real. A few right whales, a few humpbacks, but again, we don't really have many humpback call types in there anyway, so that's not indicative of whether humpbacks are actually there or not. That's why we have humans involved, and then our other sounds.
Which is sometimes more indicative of humpbacks,
True.
is the other sounds.
Very true. Yeah, glider map again, same thing that's on the project page. These are the detector classifications mapped out, so you can see those as well. Fin whale again, there you go. Background noise spectra. This is where I was trying to get to. The daily tally tables. So if you click on this, you'll see what Mark showed in his slides. So this is where you can see the summary for each pitch track period. So these are separated out into about 15-minute chunks, and you can see the summary of the classifications for each of those periods. If there's a PT link or pitch track link there, that means there's pitch track data available, and you can click right into it and view the pitch track data. You can also, for the gliders, I think for the buoys too, but obviously only useful for the gliders, you can go in and see a map of where the glider is at that point in time with the lat long. I think that's most of that page. If we go back to the project page, I know I skipped over.
No.
Oh,
no.
okay.
I saw a bunch of noise in the background spectra, and I was confused as to what it was, but I remember what it is. Never mind.
I was like, oh no. So also on the project page, this is always nice to go look at. You have the time series. So these are the human analysts results. So these are confirmed detections, red detected, yellow possibly detected, over the whole deployment. So you can see what's going on. Quite a few sei whales actually in this one. Obviously lots of fin whale, some very sporadic right whale, a whole bunch of humpback. And you get the diel plots as well. I think that's mostly it for the project page. This is just some environmental data as well that the glider collects.